Welcome back to the course Data Science by Ralph Fabric. And today let us look at inferential statistics. In the previous videos in the course, we talked about descriptive statistics and how it works. Now let us look at what inferential statistics is and how does it impact or help data science. Inferential statistics allows us to make predictions and make inferences about the data. With the inferential statistics, you can take a glance at the data and make generalizations about the population. When we make these generalizations about the population, we will be able to predict the outcomes using the data. Let's take an example. You might stand in a mall and ask a sample of 100 people if they like shopping at Sears. You could use your research to reason that 75 or 80% of population like shopping at Sears. We are making the inference that 80% of people who are in the mall like shopping at Sears. There are a couple of types of inferential statistics. The first one is estimating parameters. An estimating parameter is a branch of statistic that allows using sample data to estimate the parameters of a distribution. There are four types of parameter estimations. The first one is probability plotting, a method of finding parameter values where the data is plotted on a special plotting paper and parameters are derived from the visual plot. The next method is the least squares method, a method of finding parameter values that minimizes the sum of errors or sum of the square of the residuals. The other one is maximum likelihood estimation, a method of finding parameter values that given a set of observations will maximize the likelihood function. The least squares and the maximum likelihood estimation are a very popular type of estimation that is used in machine learning. Lastly, we have Bayesian estimation method, a family of estimation method that tries to minimize the posterior expectation of what is called a utility function. The last type of inferential statistics is hypothesis testing. This is where you can use sample data to answer research questions. You formulate a hypothesis and you do some tests to see if there's a chance that your hypothesis might be right. For example, you might be interested in knowing if a new cancer drug is effective, or if breakfast helps children perform better in schools. The first step is find your null hypothesis and your alternative hypothesis. Then state your null hypothesis and your alternative hypothesis. Choose what kind of test you need to perform, either support or reject the null hypothesis. Now let us see all the components that are in hypothesis testing. The first one is critical value. A critical value is a point on the test distribution that is compared to the test statistic to determine whether to reject the null hypothesis. If the absolute value of your test statistic is greater than the critical value, you can reject the null hypothesis. There are two types of critical values, the z-score and the t-score. If the sample size is larger than 30 and you know the population standard deviation, then you can find the z-score. If the sample size is less than 30 and you don't know the population standard deviation, then you find the t-score. Now let us see what z-score is. Z-score is also called the standard score. It gives you an idea of how far from the mean is the data point at. The formula for z-score is x, which is the data point, minus the mean divided by population standard deviation. When we're finding the z-score, we use the population mean and the population standard deviation. Similar to z-score, t-score finds the distance from the data point to the mean, but we use the sample mean and the sample standard deviation, and the formula changes a bit. The formula for t-score is that we take the data point subtracted from the sample mean and divided by sample standard deviation divided by square root of number of entries in the dataset. Confidence level is another way to find the z-score or t-score in a hypothesis testing. If the confidence interval is given to us, we can find the alpha. Alpha is the level of significance which is equivalent to 1 minus the confidence level, which is a percentage. When we find the confidence interval, this proposes a range of possible values for an unknown parameter. The interval has an associated confidence level that the true parameter is the proposed range. These are the z-scores for the confidence levels. For 90% confidence level, The area between 0 and the z-score is around 45, and the z-score is 1.645. For confidence level 95%, it is 0.4750, and the z-score is 1.960, and so on. You can use test statistics to determine whether to reject the null hypothesis. The test statistics compares your data with what is expected under the null hypothesis. Similar to how we found z-score and t-score, the same conditions apply. If it's a normal distribution with a sample size greater than 30 and the population standard deviation is known, then we use the formula above, which is the z-test statistic. If the sample data is less than 30 and the population standard deviation is unknown, we find the t-statistic. Now, the most important concept in hypothesis testing is the p-value. The p-value is the evidence against a null hypothesis. The smaller the p-value, the stronger the evidence you should reject the null hypothesis. P-values are expressed as decimals, although it may be easier to understand if you convert them into percentage, so it's much easier to comprehend. If p-value is less than the level of significance, we will reject the null hypothesis. For example, if the p-value is 0.45 and the level of significance is 0.5, which is 50%, then we reject the null hypothesis. If the p-value is greater than the level of significance, there is not enough evidence to reject the null hypothesis. So for the time being, the null hypothesis is safe. The margin of error is statistic expressing the amount of random sampling error in the result of a survey. The larger the margin of error, the less confidence one should have that a poll result would reflect the result of a survey of the entire population. So if the p-value was unable to reject the null hypothesis, the marginal error is the next go-to to see if your hypothesis is still standing strong. If you have a high margin of error, it is more than likely that the hypothesis is still wrong. The formula for margin of error is the critical value times the population standard deviation divided by population size. The confidence interval is a type of estimate computed from the statistics of the observed data. This proposes a range of plausible values for an unknown parameter. The interval has the associated confidence level that the true parameter is the proposed range. To find the confidence interval, we take the sample mean, we add it to find the upper limit or the lower limit, and subtract it to find a lower limit or the upper limit. When finding the confidence interval, we get two values. The sample mean plus or minus the z-score or the t-score depending on what you use, the standard deviation, either population standard deviation or sample standard deviation, divided by the square root of the size. Now, in hypothesis testing, there are two types of tests. You can do the one-tailed test or the two-tailed test. The one-tailed test is when the null hypothesis is the mean is greater than the value or the mean is less than the value. If the mean is greater than the value, it is called the right-tailed test. If the mean is less than the value, it is called the left-tailed test. If the sample being tested falls into the one-sided critical area, the alternate hypothesis will be accepted instead of the null hypothesis. In other words, we are rejecting the null hypothesis. Now let us look at the two-tailed test. A two-tailed test, unlike one-tailed test, has two areas where if the value falls, then we reject the null hypothesis. This happens when the null hypothesis is equivalent to the value and the alternate hypothesis is not equivalent to the value. If the sample being tested falls into either of the critical areas, then the alternate hypothesis is accepted instead of the null hypothesis. The level of significance for a two-tailed test is alpha by 2, whereas a one-tailed test is just alpha. I hope this was informative. To learn more about data science, please visit robfabric.com. Thank you and have a nice day.